Hi, I would like to show the drone console with the controlled by the WebRTC. So this project is um, to make the ground control system that very simple for the user with non-experience of drones or they are not an engineer. So the drones that we are using is running Ardupilot and it's a cube orange. So this LEPO that I'm showing to you now is the one of the part of the back end of the project. So the another LEPO is the front end, which is include the design of the user interface and about their JavaScript and the HTML. So for this project, maybe this is the hardware that I'm using. So there's a companion computer as just a nano 2 GB, which connecting to the Cube Pilot by the USB UART converter. So it's connecting to the telemetry 2, and just nano has the Wi-Fi router which has the 4G LTE, and it has one of the webcam which going to stream what's the drone, where the drone is flying. So the concept is like this, but first of all, let me show you some of the output that we have made. Then it's better to understand this diagram later. So here is the experiment system that we have tried before. So this is the screen dump from the computer, the user console on the web. And on the left side, as you can see, there's a simple map box, and on the right side is a telemetry data that's showing some basic information like position, location, and altitude, and battery, and the speed. So on the middle of the right side here is the camera, the streaming, and there's some buttons that the user can place, can place, which is the auto mode and RTL or loiter. And there is some predefined mission that user can select from this drop down. So I will just play this video and you will see. So basically the drone engineer should arm the drone to let it take off at the altitude that we want, and then the user console can just select the mission and it will just show on the map like this, and once they press the auto button, it will change the flight mode and it will keep flying. So as you can see that the streaming is quite showing in real time because we are using the WebRTC, and the telemetry data also updating as well. There's an ETA option here that showing the time when the drone will arrive. So yeah, so once the drone finish the mission, it will just stop and all will be passed, and it couldn't land, and then it would just stop at that position. So for example, like in the application like delivery the medicine over the island or some package, so this would be very useful. So the operator can be anyone who has no experience of the drones. So this is the output of what we have made, and for the structure inside of that is like, so you can check on my LEPO, the drone WebRTC control. So as you seen before that this part is just a nano, and this is the Cube Pilot. So from just a nano and the Cube Pilot is communicating by the MAV link on the telemetry 2 port. So I have the ROS node, which called the APM data publisher. It's going to connect the QPilot to the Jetson by using the DroneKit API. And there's another node which called console data receiver.py. So these two nodes are talking together by using the ROS topic. There's another layer which is the Momo, is the one of the open source project that can provide the real-time video streaming and also the data, the message from the user along with that stream. So it's very useful tools for the WebRTC application. So the Momo can take care the videos. For example, we have the depth video 0 from the USB webcam, and we need to create two of the pseudo zero port, which is the depth PTS 0 and depth PTS 1. So this two port can be created by the socat command, which I'm going to show you later. So on this depth PTS 1, it is the port where we can send the data to Momo and also receive the data from Momo, and then the data that we sent will be going to the depth PTS 0 port and pushed to the network, to the signaling server, and so on. So also at the same time, the video camera will also stream out on this port. So we are using the 4G LTE Wi-Fi router, so the robot can access the internet all the time. And so once the data going out of the network, and so we need to set up the signaling server, which can be the IMA Labo. This is also another open source from the Momo developer. So or we can run that signaling server on AWS or other server somewhere, and of course we need to have the web hosting server for our website to let the user access that. And for this application, we also set up the S3 bucket to store the mission file. For example, if someone want to update the mission on the console, like the drop down here, so they can just put the mission file like the same format of the Ardupilot is using. So we just put it into that bucket. So the Jetson Nano should have the credential to access this S3. So I assume that. Then on the user PC side, as you seen before, this console. Once you access the website, so you can see the web console like this. So on the engineer PC, as everyone knows that you can use Mission Planner to set up the cube and arm the drones and so on. But once the drone fly away from the this PC, the map link will cut off. So the user PC will be the only way that you can still have the communication available. So in this, I just explained the detail of how we're gonna run Momo and their link to check on their GitHub page and documentation. So yeah, so when you run the socat command, which I explained here, that to generate this two port, it's going to give you this two pseudo serial port, which is 0 and 1 as like a pair. So you but sometimes if you open other terminals in the same time, it will just be another value, for example like 1 2 or 2 3 and so on. So to run the Momo, if you check on this documentation, so here is some example. So you can run with this command and specify the video device resolution that you want, and of course you need to specify the serial port, which I mark as first port, which means this port, the FPTS0, and the IMA signaling server. So I'm using the IMA label at the signaling server, so we need to specify signaling key and the room ID to let the communication happen. So the data that transfer in the air is not mapling anymore. It's just a simple JSON format which we decide to use as simple like this. So it can be append to be another telemetry data. So we just grab some of the necessary like position and speed and the GPS fixed status and mode and so on. So this is the telemetry data that the drones, the Jetson, going to send to the console all the time. And from the console to the Jetson to the cube, when, for example, when user press some button, wait a second. So when user press the button like mode change here and select the mission, so the console will send back this JSON string back to the JSON. So as I explained, there's a APM data publisher node which is going to publish this and connect with the Ardupilot by the drone kit. And there's also another node which the console data receiver, which is going to take this JSON and parse that and communicate it between these two nodes. So the reason that I'm using ROS to communicate it with and split it as two nodes, because we can debug and expand the nodes once it becomes more complicated. So and yeah, it's very useful tools for like communicate between multiple nodes which need to run in the same time. So that's why I'm decide to use ROS as the communication between the nodes. And this is a dependency of how to set up the JSON Nano and the setup on Cube Orange, and the run commands to run each command in each terminal. So on the web console you will see that there is as I shown before, there's a basic telemetry data that's showing on the right side, and live streaming and the user control buttons and mission, and the left side is the map. So I will show some of the example on the SITL of the Ardupilot. So I just clone the Ardupilot software and try to run this. I'm using sim vehicle, Ardupilot with quad. So just wait a second to let this initialize everything. And the drone should appear on the map. Okay, here. So and then I need to run socat, which is the command that I explained to you before. So if I run socat this, it will generate the FPTS3 and the FPTS4. So we need to grab the FPTS3 to use in the Momo string command. So we can export console port as def pts3, and I have already have the command here. So to run momo, and you have the string. So it's gonna use my video device 0, and my webcam. So this is running on my laptop. So but basically it should run on the Jetson, but it's the same. So next I'm gonna run the ROS core, but of course you need to source of the ROS environment setup, but I already have done that. So just start ROS core on this terminal here. And another terminal, you need to again source of the ROS environment and run this console data receiver with the port, the second port from the SOCAT, which is devpds4. So I run this, then it's fine. You can connect to the, it's waiting for the data at this port. And again, I can run this, wait a second, the Python APM data publisher with the UDP localhost setup and devpds4 as the console port. The S3 here is the bucket that stored my mission file. So I have 3 mission that store here on S3 bucket, and I just run this. So yeah, just printing some information. So on the, like I can send the command like the other map proxy command as what is the command, like mode, let's say guide. So just change the mode to guide, and then okay, let's open the console now. So my console is 80 drones. Okay, so because I'm using my video webcam, so you see just my face, but actually it will be the another video, and you can see the data that's updated here. And okay, let me try to set the altitude a little bit higher. So I can do this by sending the command here, throttle, and take off 100. So okay, take off start, then the altitude just keep increasing, and on the map proxy map, yeah, so on the console also increasing. Okay, so I can select the mission here. For example, there are 3 missions right now that I have shown you before. So mission 1 will be like this, or mission 2, or mission 3. So we select mission 1. So I think the drone is already in the altitude that's ready to fly. Then the user console here, we can click auto to let the drone go. So it will change the mode to auto, and as you can see, the drone is flying. So we can change the trail dots here into something that a little bit farther away, 25 meters per each dot. So this will take a while to finish, so I will just let it fly. And at the same time, you can see this ETA of each point, and it will recalculate it every time when it reaches 1 point. So yeah, so this is how it's working. Okay, so the drone's already arrived the fifth waypoint and it's finished the mission. And then from the uh, console here, we can click another button, for example, like RTL. So it's just gonna return to launch. So the drone should fly way back to the home position. And yes, alive there. So yeah, this is the very simple console that um, we can allow non-experienced user to use the to control the drones. So here's a delete button, and yes, that's it for my presentation.